Kia ora, good evening. Welcome to one more session of Coding Nights, New Zealand. And tonight we have the continuation of Azure Durable Functions and Patterns. This is part two. So part one, we had it a couple weeks ago. So we had a hybrid session and we approached three patterns in, with Azure Durable Functions. And tonight we're gonna see the remaining three in with demos. The thing is that if you're coming to this session without any sort of context, I recommend you to watch part one, and then you can just jump straight away to part two. And because I'm not going to explain in details how things work, or um, from the not necessarily only from the implementation, but from conceptually how things work. So yeah, and tonight it's going to be me, and I don't know if you have seen like this my profile, but I'm basically a software developer and Azure specialist. I work currently at Datacom as a practice lead, also a co-founder of Playgo Kids, and my blog is tech.playgokids.com. As part of the Code Nights user group, we in general introduce the user group to developers. And basically, we're developers, a group of developers that love coding, right? And we follow best practices on software development languages and technologies. In general, we're more focused on the Microsoft stack, but that's not like a rule. So if you are keen to uh, showcase or talk about any specific technologies, languages, just ping me, and you can ping me on Meetup or directly on the YouTube channel as well. So the main intent of the user group is to enable developers so with practical knowledge to excel and launch their careers. So if you're a junior dev, or up to a lead developer, you're gonna take like advantage of those sessions. We're part of Azure Tar, cloud native user group, focus on the latest CNCF releases, and also part of .NET Foundation, entity that looks after the open source projects. And tonight we're gonna go straight away on the remaining patterns. I'm gonna share my screen here, and then from here we can continue on the slides. Let me just share my screen and bring this one. Cool. Let me jump to the presentation view, and we're gonna go from here. All right. So on the past couple weeks, part one. Oops, not this one. Would be that's a different one. Those patterns. So we explored the chaining pattern, and so we explore in details conceptually and implementation. We also explore the fan out fan in design pattern with details in the demo. We came up to async HTTP APIs, and for that one we had like an issue, and that was basically there was a quick fix, but in the end I didn't show the result on when we're querying the the function. I'm gonna quickly demo this one because now I know like what happened. And but tonight we're going to explore in details how the monitor pattern works, human interaction pattern, and the aggregator pattern. With that, let's just jump to the monitor design pattern. So this one. So with the monitor is, I think, like if we go one before, where we had the async HTTP pattern, right? So basically, let me just bring that one. So what we had in here is that on the async HTTP API pattern, we are basically doing some work, right? So where things, the function, the durable function would start, do some work, and while the state is being processed or saved, we would enable other solutions to query the status. But the focus was to do some work and enable API endpoints. With the monitor is the opposite. So what happens is that, well, we basically have this orchestrator running multiple times just to uh, query for those stats. Right? So this one is the query part, because like the work itself that's represented by this. Let me bring it again. So this would be like a regular function or any other external service that's being executed. But the pattern itself covers this part where we're basically doing like a loop in, well, in a way that we make sure that we are always querying for a status of the implementation, whatever the service it is. Right? So with that, I want to show that this is the article that covers the implementation, and I'm gonna jump to the demo. Let me just bring my Visual Studio. So in here, that's the solution that we have on the monitor, but you can see that, well, everything starts with the startup. So in here we have our dependency injection created. And after that, so as part of any durable function, we have our starter. Our starter comes, well, in this one, I call like monitor.cs, following the same sort of demos I did like in the first session. So we have monitor that contains our starter. The starters, they trigger orchestrators. Then I'm going to trigger this one. And orchestrators trigger activities. The activities are responsible for executing the whatever is being requested. And if I jump in here the codes, so let me just zoom in so you can see this one a bit better. But this is a startup, and this one we're only adding dependency injection that calls this image processor. If we jump to the image processor, well, it's just like a dummy, but it's going to process some sort of, well, an image. So that will be an implementation. And we have this method where we get the status. Just saying, okay, image processed. There should be some sort of verification process if you had like any sort of process being executed. And well, we're on the startup, but then we have the starter function. So the starter function is the one responsible for triggering or starting the durable function. You can see here we have this durable orchestration client. That's the starter. We are watching for an image DTO. The DTO itself, it's very simple. It's just like contains a file name as a string and a bytes array of a file. But it's reading that, so it's HTTP triggered. So we're gonna call it this endpoint. That there will be an endpoint that we can trigger. We're gonna receive the image, and then from that moment, we are just starting the orchestrator passing the image down, right, to the orchestrator to be consumed by the activities. And that's it. After that, we get a status response. From here, we have the orchestrator. So that's an interesting implementation because what we basically have here, it's a loop. And think about a process that could take some time. Right? When we're processing images, things are not going to happen uh, uh, immediately. They're not going to be simply executed. Sometimes it can take like uh, some minutes, right? Depending how large the process or the image is or how long the process takes. And but you can see here we have a loop, right? So we have a loop while, and what's going to be doing is basically querying for, well, while is the process within time. So we're going to have an expiration uh, time. And if it's happening within that time, okay, do whatever needs to be done. Otherwise, it's basically a timeout, right? So I think like look at those two, the while things not still under the time of process. Otherwise, it's a timeout. But before we come to that, let's see here. So here we have the DTO, then we have the polling interval, which is basically, if we jump to that, well, just return like 15 watts. It's not seconds, minutes. Actually, this is used in here. So you can see that after the loop, we're checking, we're putting, okay, the next check after 15 seconds. So the 15 is just using here to increment in seconds. We're going to have a loop. While this is not processed, because it could be another state. Right? It could be, we have two states actually, or image status. We have processing and processed. Here, just it is waiting for process. So while it's still processing, this is going to query every 15 seconds to get like the state that we need. That's the expire time. So we're just verifying, okay, is the file, well, we call this activity and verify, cool, that's running. And we now understand that we have just triggered and the expiration time is going to happen. We're setting this one for get expire time for 5 minutes. So if like the processing doesn't finish in 5 minutes, then we have a timeout. But in while this is still in process, we're going to have the loop. As I mentioned before on the previous session, so with the orchestrator, we have event sourcing. In event sourcing, we have, so the Azure Durable Function, what it does, it saves the whole history of events. And we have this replay behavior happening all the time. So if you are to debug this one, you're gonna see a lot of times things coming back, right? The replay behavior, but it's not because it's executing things all over again. No, but it's because it knows the state of where the last execution happened and it goes down multiple times. It seems like it's happening multiple times, but it's just the cursor going and verifying. Okay, behind the scenes, what it does is that it verifies. Okay, what's the latest history event? That's the execution. Okay, so the cursor is going to go. Okay, I have like lots of uh, statements, but that's not this statement. It's this one down. So we're going to see that it seems to execute, but actually it's only going to trigger what's needed. Without further ado, I'm going to trigger this one. Uh, I don't have a breakpoint in here, but I have breakpoints in the activity, right? Because, well, the first step that happens is that we're running the process. So we start with this one. So we have like a breakpoint. Second step is when within the loop is that we verify the state. Right? So get status image activity. So coming here, that's the status. So we're grabbing this every single time. But to send the alert, it's only going to happen when this is triggered, right? So when like it's processed, then it's going to call this one. Right now, I have hard coded because we're calling here the activity get status. When it comes in here, we're going to get this status, which is coming from the image processor, and that's hard coded to processed. So it's going to go in here straight away. And you're going to see that the activities they're going to be called in sequence. Oh, kind of to run the process, get status, and then send alert. I'm going to tweak that and change to processing, and then you're going to see that this one is not going to be triggered. So it's just how things, you're going to see how the replay behavior happens. So let me just trigger that. What happened last time, I think for the last execution on the async HTTP API, is that the cursor sometimes gets stuck in here under the command. It seems like the things were processing, but that wasn't the case. It's simply like the cursor was stuck. So make sure that if you see things are not working, double check that, or click like just like on the box or out of the box, Control C, Control V, or just try like to release the cursor so like the process continues. For this one, what happens that we have this endpoint that was created, monitor HTTP start, port 7207. I'm gonna bring Postman 7207. I think like let me just try to make this full screen. Cool, so you guys can see a little bit better. But what happens is that we have the image DTO that's going to represent what the content is, file name, and a byte array. And I'm going to trigger, right? And immediately you're going to see that the breakpoint is going to call Visual Studio here, right? So we have the starter in here. If I go the next line, now we have the image available, right? So I have those details in here. And then the orchestrator is going to start. I don't have any breakpoints in here, but I know that they're going to call those activities. Let's see. Let's continue. So with that, now we have the execution coming from to process the image. That's going to trigger the process. So that's going to be the first step. Then the second step is to query for the status. The status that's going to come in here is processed, right? And because it's processed, it's going to send an alert. So if I continue that, now we're going to see that the activity is going to be triggered. Send alert. So that would finalize well, and that's the end because that's part of the execution, the last part. And then things were executed, right? Um, let's modify the contents in here and make sure that we have that behavior of a continuous retrieval of the states. So if I come in here and change to processing, I'm going to save that. Hot reload. It's a really cool feature. Let's do a hot reload. That's it. So now I'm just going to go back and try the same. All right, so we're going to capture the starter. That's going to call the orchestrator. And first thing, we're going to try the processing. And then we're going to have the state. But the state this time is going to be processing, which means that, well, uh, we're going to have the next check. All right, so next, after 15 seconds, things are going to be triggered again. It's interesting that right now it just seems quiet, but like in 15 seconds, we're gonna notice that, well, actually the activity in here, the status, is going to be triggered again. So let's just look at that. I think 15 seconds should be coming. And then we should have the endpoints. Yes, it came. So that was like the check, right? What I'm gonna do here is that I want to come to this. Rather than return processing, now I want to modify again. Processed. Let me save. Hot reload. Now I'm gonna do processed. So this one now has finished, right? Because now it has passed, and there's a break statement. It's gonna go out of that, right? So actually, first it's calling the activity to send the alert. Then it's gonna go out and call this one. So if I go back, activity send alert is being triggered, and the end of execution is the process within the time. Yes. Then that's finished. Yes. That's the, let me just come back to that. So that's the monitor part. And what happens, as you can see, so we would just have like this execution uh, in a loop. And this loop would just follow every 15 seconds until we get a state that's the one that we expect. With that, let's go back to the presentation. This one. All right. So that's the monitor pattern. Let's go to the next pattern, which is the human interaction pattern. Well, as the pattern indicates, we're going to have like a human in the middle of the process. Let's say we have a starter that's for an approval. So it could be like any expense claim, for example. So we're going to request an approval. The approval is going to be sent to a human, and this person is going to have expire date as well. And if this person responds in within the expire time, so that's going to, it's favorable, it's going to process the approval. If this person fails to approve or decline, then it's going to be escalated. So you can see that we have like a way of intervening in this pattern. This is the link that contains the demo, and let's jump straight to that. I'm going to stop this one. Let me close, and I'm gonna open the human interaction pattern. All right, same as before. So we have like our dependency injection coming here. Then we have, following the same sort of approach for the nomenclature, this is the human interaction that contains the starter of the function. The starter calls the orchestrator. The orchestrator triggers activities for execution. On this one, right? So the starter is just a notifier. The notifier itself is a dummy, it doesn't do anything. But if we were to have some sort of notification, we would have like that implemented. After that, we have the starter. So the starter, what it does is just receives an expense claim. This expense claim, if I am to show, is just like description and a cost. As simple as that. But then, so this is a starter that is a HTTP triggered. So we're going to have an endpoint, and the expense claim is pushed down like through the orchestrator. Within the orchestrator, Here we have like an interesting implementation. All of those details in here, it's good that they are presented because uh, without knowing, I mentioned like the previous session, when you don't know really Azure Durable Functions, exploring the patterns help you understanding the statements and uh, how things work. So I would definitely recommend like those patterns to be explored because with that you have like a better understanding of the whys. You can see things like context and because the orchestrator itself is a special uh, case, right, where we have event sourcing. So everything, the orchestrator is special. The other implementations are just ordinary, right? So it's important to understand how the orchestrator works really well. So in here, so we had the starter pushed the expense claim. From here, we're gonna send a request for approval. This could be, well, for this one, if you look at the activity itself, it's just send a notification. So imagine we're sending a notification to a person. They're gonna know that there is a expense claim for approval. But what's interesting, what comes next? Because in here, what we're doing, we are putting, well, we have like a timeout, but that comes with this cancellation token source. So what it does is that, okay, it produces like this can cancellation token that depending on when this one expires, it triggers a way for you to verify uh, by verifying an error or things were really canceled or not, because you're basically flagging, okay, this is a cancellation token. But when you are associating that with a timer, you basically have a state that tells if things were canceled or not. But you can see here, so this is due time. The due time is adding hours to this timeout. Well, it doesn't show in here, but like you can see, it's 72 hours. If I was to show like that, that's it. All right, 72. And I'm just hovering here, but the hovering is not being displayed in full. Let me change the view. Yeah. And so with that, we have the due time, and the due time is, well, created from the context, right? Previous session, I mentioned that everything that happens within the orchestrator needs to be deterministic, which means we know that what's going to be the next execution, right? It needs to have the same results every single time. So that's why we're not binding this date from the, well, the date time, right? Or from the C sharp. No, that's coming from the context. The context comes from the event source, right? So that's important to use the context. And here it creates a timer, a function within the context that allows us to create these timers within Azure Durable Functions. And here we assign the token, right, for the cancellation token. So when the due time happens, well, the cancellation is simply gets like a flag that, and that triggers a cancellation event, which is, well, you're gonna see here that the durable timeout is used in here. We have this task when any, so that's a task that's going to listen for either this approval event or the durable timeout. It could be one of those, right? If the person is going to, this is what happens there, like the person received the notification. We're going to be listening for an external event. So this person needs to somehow push a message back to us. So that's a interesting implementation from Azure Durable Functions. We're basically listening for this event. So when this happens or the timeout happens, we're going to have a result. If it has expired, the result in here is, well, when it says here that result is completed, for both, if it was expired or if it got an approval, even a response, well, we got like a result. That's going to be completed. But what happens is after this action, because if it was approved, if that's like a true, it's going to run the process approval. If it has expired or if the person declined, then it's gonna go in here and run the escalation. So in both ways, we have a way of uh, covering, right, for that, run the escalation on that. So that's basically how things are implemented. What I find really interesting is this one, to wait for external events. In the Azure function itself, produce an endpoint that we can trigger. Let me just show this being executed, because it's going to give you a better understanding. So this is being raised. So let's see. So we got this endpoint, human interaction starts, port 7053. I had something here, 7053. So we have this expense claim. That's, well, maybe if I come, right? This is the endpoint, that's a post with the body and contains the expense, right? Description and a cost. That's basically what we have. We can just trigger that, and it's going to read that expense claim. So if you're looking here now, so it contains the detail, the lunch with the, uh, well, that's not like visible when I zoom in, but the object was created, and that's going to push to the orchestrator. That's going to be triggered, and now the orchestrator is going to start. It's going to send a notification. I think I put, let me see if I put it activity. Yeah, I put breakpoints in here. So we're gonna see those being triggered. So we're running the request for approval and we're sending the notification. All right. And what's gonna happen is that the notification at this stage has happened, but well, we have the other uh, commands. That's going to be created until the next event is to be awaited. So it's going to create the token, the timer is created, and now we're going to be listening for the event. That's the interesting part because, okay, imagine that we had the email or a message sent to the user, and now we need to notify, right? So I'm gonna go as a user and say, okay, approved. Could be a button or a page. What I'm gonna do in here is to leverage this endpoint. So we have this endpoint in here, send event post URI. Interesting is that you're gonna see that event's name is here, right? So this needs to be replaced by the event that we called on this function. Let me just copy this, okay? I'm gonna come and put in here. And for the event name, let's go to the function itself, because the function is going to wait for the approve event. Not sure if you can see, but this is showing approval. So that's the one. So when I come in here, event's name, let me just show. Right? I'm going to replace that. Oops. So that's going to be approval. Uh, remove the brackets. So coming back to that, right? So I have replaced the event. With that, another thing here, if I am to submit like a text, well, true, I'm approving. Well, it's going to complain because it needs to be a JSON. So make sure you're always dealing with JSON. That's going to be triggered. That's my saying, okay, it's approved. Well, it came back to the function, right? This time around, it's going to go in here and we can verify the result, right? So it passed, right? So we have the replay behavior is just executing. And from here, we're going to see, okay, approval events. So we had that. Well, what was the approval? Approval was, it's just weird the way how it's printed, but the result was true. So that was true. But the execution of the task, either this or that, it happened, it was completed. So what is going to happen now is that like the approval result, it is true. So this one is going to run the process approval, right? And that's going to trigger my activity for that, which is pretty cool. And you can control like depending on flows that you have, that you need to have some sort of approval, a person in the middle. That's replay behavior gonna finalize the execution. It's not executed again, but it's just finishing. And that's the human interaction. It's really interesting one if you want to have better control uh, programmatically from code on how to do approval workflows. That's a good pattern to use. Let's go back to the presentation. And now we have the aggregator pattern. This one, well, we talked about these durable entities also in part one. But what these durable entities are is that is an entity that you persist state. So let's say that we have functions that are being executed uh, different times. Let's say if you have a counter, you would trigger things, you would preserve those counters every single time they are triggered. You could do like you could just increment, you could get those results, you could update or change or delete those states if you wanted. In this demo, so you're basically just submitting more and more states, and those are going to be recorded. One of the things is that we have this entity trigger on these entities, and they control. Actually, you determine, you define how things are going to behave. You're going to add, you're going to remove, you're going to reset. I'm going to show this one. This is the link, but let's jump to the code, and then you can see how things work. Let me close that, and let's go to the aggregator. All right. This one is a little bit simpler. When you look in here, I just put like as a function itself in the aggregator. We have this voting counter that contains how it deals on how we increment or control the states. Let's go in here, the voting counter. What we basically have here is a dictionary. It's a dictionary of a string and integers. With that, we are saying, okay, we're doing like a vote for a candidate. And we're counting the number of votes. So that's why the name of the candidate and the counts of votes. I have like other methods for adding, retrieving, or resetting. right? So that's basically what the implementation I have in here available. One of the important parts is the not aggregate. Let me pull like in here, the entity trigger. Well, you can see here that we have the context, but we're just saying, okay, depending on the operation name, I'm adding, I'm incrementing that. I'm resetting the state, I'm getting the state, or I'm deleting the state. And the aggregator here is my starter. I have two triggers in here. For this one, I have a queue trigger because I'm gonna vote for a candidate. I decided to do as a queue trigger. So I'm gonna put like a message on the queue containing the candidate's name. And what we're basically doing here is that we are adding. We have this entity client that's gonna signal to the entity, do add operation, right? And that's basically what we're gonna be doing, triggering on a queue. What we can do later on is to retrieve, so we can read the entity state, right, of the voting counter. So just say, yep, I want to read who won. I could do that, and I would get like the final result. If I am to play this one, let's get like this one in action. Let me bring full screen. Okay, this is triggering, and we're gonna validate this voting counter. So we have in here, well, HTTP trigger and a queue trigger. We need to create this queue, right? So in general, I use this tool, uh, the Storage Explorer. So we need to submit a message to the queue, and the queue is going to trigger our entity trigger. Let's just see here. So we have the emulator. It's running locally. Let's see the queues that get loaded. I don't think I have it here. Otherwise, I would just create a new queue. Like the queue needs to be the one specified as the name of the constant that's in here. This one, vote-q. Vote-q is here. All right, so, well, I'm gonna create a message. I'm gonna vote for a candidate. Let's say I vote for SpongeBob. And that's going to record it's gonna trigger. Can you see here? So it got triggered. So it was listening to this queue. You verify that, okay, that's the entity that you're trying to submit. I'm gonna push the candidate, SpongeBob. This one is going to trigger the entity trigger. For that, I don't think I have enabled the states. Let's see. Actually, I do. I had like previously checked, but yeah, I had like a previous state, so it's not creating one from scratch. Anyways, but that demonstrates that the state for my example that was executed some time before this demo still there. So we're gonna add the candidates. That's going to be uh, well, that was added, right? And it's gonna save the state. Well, the queue in here no longer is available. Let's say another person comes and then they want to vote for someone else, right? Patrick, and they're gonna submit like a vote. In the durable entity, it's going to be triggered again, right? And if I come in here, so let's see in the votes. Now I just dive in. It's gonna verify, okay, it does contain this key. Yes, it does. So just count, just increment one more vote. Okay, but like then we want to verify, well, what was the endpoint for me to verify the result? That's the one. So I could just query that. Port 7007 HTTP trigger. 7007, I think that was HTTP trigger. Let me trigger that. So now we're trying to read the state available. We're going to read that. It's going to return the votes. Right? So that's the entity, the durable entity. We have like 3 votes for SpongeBob and 2 votes for Patrick Star. So this one is going to be persisted, and while I have this durable function running, I have control of that state, right? I think like with that, we basically covered the patterns. I think like there's a lot of value in exploring those patterns. If you have like a programmatic control over workflows, Azure Durable Functions are the way. And you can basically control logging. You just define implementation yourself. Right? You have a lot of flexibility in scale as well on Azure that would handle that on your behalf. I think like with that, we're basically getting to the end of the session. If you have like questions or maybe put like on the chat or otherwise ping like me on the meetup. But I hope like you got the most out of those sessions. And right now, this is like December. We're gonna have a break, and we're gonna come back in January. So until there, like I wish you guys are like a Merry Christmas and Happy Holidays. And I see you back in 2023. I think this is it. And I hope you guys have a good night. Cheers.